Let's move to the homework set number 3. In the first task, we would like to do the count primes, but we should avoid using loops at all. When you think about count primes, we actually have to split it to two functions. A function that iterates on the numbers from 10 to 20, for example, and a function that is checking if a number is prime or not. So this is one step here. And remember, we have this principle in software engineering, the single responsibility principle. The count prime here is doing two things. It is iterating, it is verifying if a number is a prime. So we should split them in two different functions. Now let's try to see how can we avoid the recursion, the loop when it comes to the count prime itself. The count prime can keep calling itself with count prime with start plus 1 and end. So we have a function with start and end, and it's going to check if the current number is prime or not, and then count the primes number in the remaining of the range. For example, count primes of 10 and 20 is going to check if 10 is prime number or not, and then it will check if from 11 to 20 are they primes or not, which again in the same way is going to check if 11 is prime or not, and after that will check the range from 12 to 20 is prime or not, and so on. Again, in terms of what and how, what does the count primes number do? It counts the number of primes from start to end. Then what could be a good base case? If the start is greater than end, we are done. What is my recurrence? I'm counting the prime numbers from the number after the current starts, and I'm checking the prime for the current start. With these two things, focusing on what and not on the how, you can easily understand the function. So with the start plus 1 track, we managed to do the count primes without loops. Now moving to the is prime number, again the plus 1 track is going to be the same. I have here a function that it take a prime number, but it take a number that is the current check. Remember, when we would like to check if a number is a prime, we iterate from 3, for example, up to the number. Yeah, I think actually, let me try that. I think as an improvement, we can have here this one as 2. Yeah. So I'm starting this number here with 3, and I'm here validating the 2 as a special case. That's why we can keep counting it only plus 2, because we are now checking only odd numbers. The logic here, if it's even, if it's 2, it's a prime number. If it is less than 1 or divisible by 2, then it's false. If we are done, that we are in the end of the loop, then we are done. Then the number isn't divided by any number less than it. If we aren't done, and I can be divided by the current test number, then it's false. Otherwise, I am recursing with the current test number and plus 2. Let me define what is this function really mean. We know that is prime of m is just counting, is just checking if a number is prime or not. But with this extra argument here, I mean starting from it checking for the current number. Like for example, is prime of 103, will it check the numbers from 3 to 100. Is prime of 117, will it check if from 17 to 100 is there any number that can 100 be divided by it or not, and so on. I hope you aren't confused with the function for now. So all what happened is, instead of for loop for current test number from 2 or from 3 to m, check if the number is divisible or not, to let's make this number to keep being passed here recursively one by one.